Today we received the 440 Newton shaker from Dynalabs, and we're pretty excited to get it into operation. Hi, I'm Mark from Peak G, and today we're going to do exactly that. We're going to unpack everything and then walk you through step by step how to connect the blower and amplifier to the shaker, and then we're going to run two different vibration tests. The first one using the Sine generator built into the amplifier, and then the second vibration test using an external vibration controller from RULA Technologies. All right, grab a coffee, sit back, and let's dive right in. You'll need some tools, an H10 and H4 Allen wrench, a standard 12mm wrench, and a flathead screwdriver. The shaker system will arrive in its own carrying case with some accessories. First will be the shaker body itself. There will be a BNC cable that connects between the amplifier and an external vibration controller. Then we have the power cable that connects between the shaker and the amplifier. And here we have a cooling blower hose connector. This is the one that connects to the shaker. There will be 9 M6 screws that attach your test item to the shaker armature. Some fuses for the shaker, and we'll show you how to change those at the end of the video. There's another connector for cooling the shaker using compressed air. And finally, there's an operation manual. There will be a link to download this manual from our website in the description below. The power amplifier will also come in its own carrying case along with a few accessories. We have the power amplifier itself. We'll go through each component and also show all the connections a little bit later in this video. There will be a standard power cable and a couple of fuses. Next is the cooling blower. The blower includes a soft start circuit along with a long power cable. Take note that the blower has an inlet and an outlet. Here we have the cooling hose and a hose connector. And finally a couple of hose clamps. Alright, the first thing we want to do is position the shaker on a solid, stable surface. You can rotate the shaker body by loosening up these trunnion handles. The handles themselves are spring-loaded, which allows you to rotate them once you've locked in the shaker position. Now let's connect everything. We'll connect the amplifier cable to the shaker first. The connector has a locking clip and you should hear it click when connected. Now we have to remove the cooling plug from the shaker using an H10 Allen wrench. Then screw in the hose connector. Now connect the hose and use one of the hose clamps to secure it into place. The shaker needs to be cooled by drawing air in through it. So we'll connect the hose to the inlet side of the blower. Plug in the blower and it should start right away. You can confirm the blower is connected correctly by putting a small piece of paper on the shaker vent hole. Now let's do a quick walkthrough on the amplifier. We have the display window. We have a switch that can select between using an internal or external drive signal. We have a gain adjustment knob, and we have an internal sine frequency generator. This signal generator can only be used when the switch is set to the internal mode. On the back of the amplifier we have the fuse holder. We have the main on-off switch. We've got a connector for the power cable. We have a BNC connector for an external signal input, And we have an output connector that connects to the shaker. Connect the other end of the amplifier cable now. Turn the gain knob down to 0. Connect a power cable to the amplifier and the other end to an outlet. Now turn on the amplifier. Make sure the switch is set to internal mode. Adjust the frequency to 1 Hz. You can also select a higher frequency. I'm using 1 Hz so you can easily view it on this video. Increase the gain until you see the shaker armature begin to move. So from this you can see increasing the gain will increase the shaker amplitude. And vice versa, decreasing the gain will decrease the shaker amplitude. Now we're ready to run our first test, and we need to mount our test item. There are 9 threaded holes on the armature that we can use to do this. These screws require the H4 Allen wrench. Be careful not to over-tighten the screws. If you use any cabling, be sure to leave enough slack for movement, but otherwise tape down the cable with a couple of strain relief loops. For our first test, we're going to use the built-in sine generator. First set the frequency. Then adjust the gain until you get the desired amplitude. You can also adjust the frequency and sweep up or down if you're looking for product resonances. You can automate the sine testing or run other test profiles by connecting to an external vibration controller. For our second test, we're going to connect an external vibration controller and run a random vibration test profile. Here is a vibration controller from RULA Technologies. Check out the link in the description for more information on this controller. In this setup, we'll also connect a computer to the vibration controller and set up our test profiles there. Let's go ahead and connect the power cable to the vibration controller and plug the other end into an outlet. We'll also need at least 1 accelerometer for the control loop. Here's one from DJB Instruments, link below in the description. We'll use some petro wax to attach the accelerometer to the shaker. You don't need a lot. We'll also need to connect a cable from the accelerometer to the controller. Be sure to tape down the cable with some strain relief loops, leaving a little slack for movement during the vibration testing. Connect the other end of this cable to one of the inputs on the vibration controller. Now grab the B and C cable that came with the shaker and connect one end to the output side of the vibration controller and the other end to the input side of the power amplifier. Turn the amplifier gain knob down to 0 and switch to external mode. Now connect an Ethernet cable between the vibration controller and your computer and turn the vibration controller on. I've already downloaded and installed TestUp controller software. I'll go ahead and open up the program. I'm going to head over to Configuration tab and then click on Hardware, and I want to make sure that I'm actually connected to the controller right now. I'll select the default configuration. I can see the serial number of the controller I have, so we're good to go. Okay, I'm going to go back to the Configuration tab and then select Channels. And here we have to tell the controller software the sensitivity of our accelerometer. I've already set this up, and here you can see on channel 1, the sensitivity is 94.47 millivolts per G. This accelerometer is an IEPE type, so we have to select that here so the controller can provide power to that accelerometer. Everything looks good, we'll hit OK. And next we'll go to the shaker database. Here we have to tell the controller software what the specifications of the shaker are. And the software will use this information to prevent us from setting up a test profile that is outside the limits of our shaker. You can find the shaker's specification details in the operation manual. I've already set one up for the PM-440 shaker. Alright, let's go to the main tab, and now we'll set up our random test profile by selecting the random test module. So a new blank random test profile opens up, and here at the bottom you can see values for acceleration, velocity, and displacement. Everything is showing green, which is good, but we haven't entered any information yet. If we jump to the Limits tab, here we can select which shaker we're going to use for this test profile. We also need to enter how much mass we're going to be testing today. The controller software will then calculate if we have enough force to do this test. Now let's jump to the Channels tab. Here we're going to assign the channels configuration that includes the DJB accelerometer. We'll assign channel 1 as the control channel and then disable channel 2. Now back to the Profile tab. This is where we define the random frequency and amplitude breakpoints. We can click on the Add button to add additional breakpoints. You can enter these details manually, or with the RULA controller you can copy and paste a breakpoint table from Excel and paste it directly into the Profile tab. Once we click Apply, you'll see that the software has done the calculations for acceleration, velocity, and displacement. Everything is showing green, which means that this test profile is within the shaker limits. We'll go ahead and save this test. The last thing we need to do is go to the Schedule tab and set some time for this test. And here I'll set a time of 5 minutes. And now let's set up our graphs. I'm going to go ahead and turn off the response trace because we only have one accelerometer, which is the control channel. I'm also going to increase the line thickness so it's easier to see on this video. Okay, just one last thing before we start the test. We need to turn up the gain on the amplifier, and a good starting point is about 50%. You will also need to start the cooling blower if you're running a test above 200 newtons. Now we'll press the Run button to start the test. The controller will output a low-level signal and then ramp up to full level. Once the test has stabilized and within the control tolerances, the runtime counter will begin. We'll go ahead and stop the test. I'd like to show you one additional feature with the RULA controller that's included as a standard feature. Let's go back to the Channels tab under Configuration, and if we go over to the right, we see Digital Inputs, Digital Outputs. Here we're going to turn on Use Digital Outputs. There are 8 digital outputs available. I'm going to select output number 8 and select Test is Running. And what the controller will do is send an output whenever you start a test. We're going to use this output to trigger a relay board, of which the cooling blower will be connected to. The RULA controller has a DB37 connector where the digital inputs and outputs are wired to. Here we've wired the relay board to a DB37 male connector. And here we're connecting to the RULA controller DB37 female connector. And here's a look at the relay board inside the interface box. Let's go ahead and apply these changes and start the test. The controller will now send an output that triggers this relay board. The output is live as long as the test is running. Always disconnect power first before doing any maintenance. If the amplifier has power to it but won't turn on, you can check and change the fuse on the back. The shaker also has a fuse underneath the top cover. First you'll have to remove 2 O-rings holding the mesh fabric to the armature. Now unscrew the top cover. Carefully lift the cover up. Make sure the replacement fuse matches the same type, amperage, and voltage rating as the one you removed. Don't forget to reattach the 2 O-rings. All right, I hope you found this video helpful, and if you have any questions, you can reach out to us at the number or email listed below. Thanks for watching, and we'll see you in the next video.